Greetings, Paula Chance here, part of my Future of Manufacturing series, Artificial Intelligence and the Digital Maturity Model for Manufacturing. Are you smarter than a chimpanzee? Today we'll talk about what we can learn from our primate cousins and ancient ancestors. We'll talk about how quickly things are happening, the compression of time, how AI benefits manufacturing operations, and automation and artificial intelligence, how they actually empower people. Things have really changed on this planet for humans and for industry. Homo genus, our early ancestor humans, have been on this planet from about 2.5 million years ago. We, Homo sapiens, about 200,000 years ago. There was an important event related to our intelligence called the cognitive revolution, which will tie into modern artificial intelligence about 70,000 years ago. We've been in an agricultural revolution where things really started to settle down about 10,000 years ago. And then as we hit the industrial revolutions, which only started about 238 years ago, things really started to speed up. From a technology standpoint, computers, it's only been about just barely over 60 years since we had real usable mainframe computers and PCs. The internet only about 39 years ago, and it's only been about 12 years since the first iPhone. That first iPhone was approximately 120 million times faster than the first computers that were used on the Apollo spacecraft, which took people to the moon. So amazing compression of time that has happened. The industrial revolutions are going through the same compression of time. The first industrial revolution in the late 1700s was a major technology change where mechanization was possible. That's where we were able to harness steam and water. The second industrial revolution was all about mass production in the late 1800s. Think of the Henry Ford Model T, actually started sooner than that. Electrical energy helped in that revolution as well. Again, another major technology shift. The third industrial revolution was all about automation combined with computers and electronics. And we started to see early versions of robotics. And the fourth industrial revolution, or Industry 4.0, is everything we just talked about, but everything is interconnected. Cyber physical systems, the Internet of Things, the networks, cloud. Fourth industrial revolution is actually a combination of lots of different technologies. Artificial intelligence, which we're featuring in today's presentation, is one of many. In all cases, with these technology shifts, with the industrial revolutions, translated to major human progress, not only in industry and in manufacturing, but across the planet. In terms of GDP, exponential improvements, life expectancy, exponential improvements, poverty, people not living in extreme poverty, way up, people living in a democracy, so exponential that I had to blow up this scale. So technology can be directly correlated, these industrial revolutions can be directly correlated to human progress. The digital maturity model is a way for you to look at where are you in your journey to harness Industry 4.0. And it's not a destination, it's a journey. So when you look at this diagram here, as you go up, the value increases. It's also more difficult. You start off with computerization. You just have to have computers. That is an absolute non-starter. Connectivity. So this is where you can start to integrate your information technology, your occupation, your operational technology from your manufacturing and business functions. That's where you have to have good networks, start to take advantage of the cloud, not only for your people and computers, but all devices in your manufacturing operations. As you move up this, you get into visibility. That's where you can start to really capture information, digital records, where you can start to make real-time data-driven decisions. Things really start to get cooking at this fourth level with transparency, where you start to be able to really determine new insights and analytics, especially in areas that are physically and, say, data difficult to connect to, where you can really start to see and make improvements. Predictability, that's where you can get automated analysis, where you can start to catch problems, think, say, predictive maintenance, and streamline remedies that would be very difficult to take if you just had to do that on your own. And the holy grail, this adaptability, is where we start to get into prescriptive actions. That's where this artificial intelligence and other technologies can suggest, and in some cases, automatically self-correct actions based on taking in all that data. Industry 4.0 has a lot of other promising technologies. The Internet of Things, which is how can we have our assets and our facilities tell us when they need help or when they need to be maintained or deliver data for other analysis. 3D printing, the ability to print up spare parts, or in some cases get into additive manufacturing, which is essentially 3D manufacturing, 3D printing at scale. And that includes not only plastics, but metal and more advanced topics such as digital twins. Digital twins are living, breathing digital versions of their twin real world asset. And having these digital twins, especially combined with artificial intelligence, we can find problems that are going to occur with this asset before they ever occur. We can try out models, we can catch maintenance issues, we can even look into design improvements on these assets, all in this artificial intelligence computer environment. Augmented reality, assisted reality, and virtual reality show another amazing promise in Industry 4.0 and the exponential technologies. So assisted reality is a great way to see where you have, say, the aging workforce. People can talk into your ear, show you information on your screen, so the younger generation can perform duties with guidance. Virtual reality is a wonderful way for training and other activities. And augmented reality, which I think has amazing promise, is the ability through these lenses, these augmented reality lenses, think HoloLens, where you can have preventive maintenance or other sort of operational instructions just floating in the air. It gives you hands-free mobile control and can even give you training and alerts. These things are not really in green or red, but if you make a mistake, that augmented reality can help you. Artificial intelligence is one of the main aspects of the exponential technologies, one of the main parts of Industry 4.0. By definition, AI is a wide-ranging branch of computer science concerned with utilizing smart machines capable of performing tasks that typically require human intelligence. AI actually has a subset called machine learning and deep learning. Artificial intelligence is the acquisition of wisdom, basically where computers can make human-like decisions. Machine learning is the acquisition of knowledge. This is where machines, typically computers, can take in data, use statistical tools and algorithms to explore that data. Deep learning, which we won't get into in this presentation, is machine learning at scale, and it really tries to mimic the human brain. Machine learning examples like talk to text or facial recognition. Facial recognition, every time you look at that phone and it unlocks, as it starts to take those images in, it knows as it starts to sense subtle changes in your face. You might be more tan. You might have changed your haircut. You might be wearing a hat or sunglasses. You might have shaved or added a mustache. So the machine can learn and continue to unlock your phone. AI, that's where the wisdom kicks in. And one of the best examples is streaming services like Netflix. It always seems to know what I want to watch. And it does that through taking in, through the machine learning, what I've searched on in the past, but other sources of data, such as time of day or time of the year. Are there holidays coming? And it puts that all in a blender, and it can suggest intelligently, like a human might, what I should watch. This translates to other activities such as online banking, and of course, autonomous vehicles, self-driving cars is an excellent example of machine learning taking in all this data from the surrounding environment and be able to ultimately pilot your vehicle. There are great promises and there are risks to AI in manufacturing. Now, I'm going to stay away from the whole Skynet, robots, artificial intelligence is going to take over the planet. I understand that there's some concerns around this, and we as humans must really plan for a future in AI. I mean, all new technologies that have come, including things like fire and steam and electricity, have caused concerns. AI is a bit more intimate, and we really have to plan for it. It shows amazing promise, especially in manufacturing, in terms of efficiency and productivity gains, faster decision making, reduction in errors, taking risks instead of humans. AI enabled robots is a great example of that. It's always working, and it helps us be more creative, where we can focus on, say, new products, new inventions, and ultimately gives us as manufacturers a competitive advantage. There are risks. It's not inexpensive to create this technology, to implement this technology. There's definitely a return on that investment, but you have to invest. It will create some transitions in terms of jobs. The mundane jobs will be eliminated. We see that in the factory floor around automation. That will continue, but these jobs will be replaced with others, which we'll get into later. Cybersecurity is always an issue and has to be front and center with any form of Industry 4.0, especially artificial intelligence implementations. It's not all good at AI. I mean, you can have incorrect AI algorithms, maybe bad sources of data that might lead to bad decisions. That's why it's important that you take a solid approach. And, at the end of the day, it's not human. It can't think out of the box, and there's no emotion. So we're going to go through a thought exercise right now where we're going to overlay our closest living relatives, the chimpanzee. We actually share 98% of the same DNA as a chimpanzee. And chimpanzees are remarkably smart animals. They have all kinds of communication they can do with one another, and facial gestures and sounds they make. And in fact, they can communicate with each other quite effectively. An example, a family of chimpanzees is headed over to the watering hole. And when they're on their way, one of them spies or smells a predator, let's say a leopard, and is able to create an alarm, an alert, and all the fellow family chimpanzees are going to heed that warning and climb into trees to escape from that. Fast forward to modern Homo sapiens, humans, and remember that cognitive revolution about 70,000 years ago. That allowed humans to think more in the abstract, to understand stories, not to just have to see things or smell them for their own eyes. The same example might be an early ancestor is headed to that same watering hole, sees that same leopard, carefully backs away, goes back to their family and says and communicates to them, hey, I saw a leopard down at the watering hole. We probably should go to a different watering hole and escape that danger. Modern humans, we might have a different story. It might go like this. My remote camera picked up an image of a leopard at the watering hole, and sensors indicate she's pretty big, as well as heat signatures from other sensors indicate there's multiple leopards there, possibly cubs. AI from previous analysis indicates she's headed away in a safe direction from the family. However, I've set an alert to all our other family members. Let's go to a different watering hole. So you can see how we've progressed as humans with our intelligence. Modern Industry 4.0 manufacturers have the same abilities. If you look at your factory and you can have very basic alarming, an asset has an issue, you can be alarmed. You get a light that shows up. Now, it's still somebody has to go and look at that asset. They're going to have to go investigate, figure out what's going on. So it's better than nothing. And by the way, if you're not getting any alarms off your assets, you're probably not really much smarter than a chimpanzee. Fast forward to a more modern strategy, and we can not only take that alarm off those assets, we can get all types of data off those assets that through the Internet of Things can be integrated with dashboards and KPIs and metrics, where a human can look and say, hey, there's an alarm on an asset. I see it's a high temperature alarm. I'm going to go ahead and, as a human, make a decision to send a technician to go over to investigate. So it's definitely better than just a straight alarm. Fast forward to an AI environment, Industry 4.0, where we can take the whole next level. And we may never have seen that alarm ever happen in the first place. We were able to, through digital twinning and other forms of artificial intelligence, we're able to catch that problem with that asset well in advance and either initiate some sort of a prescriptive or preventive action to avoid that alarm ever going off in the first place. In some cases, we might even be able to control that without ever knowing that asset had an issue autonomously. And that's one of the amazing things about how AI and Industry 4.0 technology can help us. So as we go through some more specific manufacturing examples, it's important that you understand the concept of overall equipment effectiveness. This is a key manufacturing metric, and it basically describes how well an asset is performing or a production line is performing. And OEE has three factors: availability, performance, and quality. It's pretty straightforward how it's calculated. It goes from 100% down to 0%. And basically, if an asset's scheduled to run, let's just say for an 8-hour shift, if it runs that whole time, well, you have 100% availability, but you don't always run the whole time. You have tool changes, production line changes, safety meetings, unexpected downtime that takes away from that availability. Performance is about how the speed is. If we normally run and create, say, 100 parts or 100 widgets per hour, if we get 100, we're at 100% performance. If we have any if we had to slow down or had issues, we had speed losses. That will take away from the performance. And quality, same thing. If you were expected to make that 100 parts in that hour, but you had some you couldn't use, you had scraps and losses, well, you didn't have full quality. So we're looking to get as close to 100% OEE. In reality, we may not be there. It's a key metric to determine how effective our operations are running. And we strive in a modern manufacturing environment to hit as high of an OEE as we can, because it translates to better operations, ultimately to better profitability. AI can be instrumental in helping promote efficient improvements like improving OEE. AI data is absolutely essential so that we can make these improvements. So AI requires next level data. There's a concept of the unified namespace. This is a developing concept that will be instrumental in modern AI environments, Industry 4.0 environments. It's a central repository that consolidates, contextualizes, and normalizes enterprise data. It gets the data from all sources. It's coordination of tech, people, and processes to securely deliver. And it's grabbing data from all of our typical business applications, as well as outside sources. So when you look at manufacturing operations management, sort of the family of operations related applications, and you can read about what they are over here, but manufacturing execution systems, all of these different applications need to share information with each other in theory to make highly accurate, predictive, and ultimately prescriptive suggestions. All of this data is coming off the factory floor and integrated from all these sensors and SCADA systems and PLCs and HMIs, and anywhere there's data that can be delivered from the factory floor, typically through some sort of an IoT or analytics platform, into this unified namespace, we have an opportunity for all these applications to share that information for making the best possible predictive and prescriptive suggestions. Let's go through an example. So if you have an AI, ML, optimized environment. We'll do a scenario that we have a production line where the OEE is starting to slip. Remember, that's that key metric. It's starting to slip. We're seeing it in a 7-day average. Well, we need to figure out why, because declining OE will translate to all kinds of problems at the and most critically, profitability for the organization. So first off, you have to be able to measure OEE, and that typically is done either with an IoT or a manufacturing analytics platform, in some cases in a manufacturing execution system. But you got to be able to get that OE, you got to get those OEE values, so we know there's a problem. So if you look at the different technologies on our factory floor, Industry 4.8 technologies, well, in this case here, we've got some IoT sensors, vibration sensors in particular, using machine learning and taking in all of those values off of an asset, comparing them to historical values. We were able to indicate, or electronically, through machine learning and artificial intelligence, we were able to indicate there's a slight anomaly with this production asset. We're also able to, with our quality and calibration monitoring IoT devices, on the other end of the production line, is we're able to indicate a minor but potential client impacting issue. So your quality management system needs to be alerted, and inspections and possible calibration might be needed. Again, these things are subtle. We're catching them very early, and not with humans, but with IoT, with turbocharged with AI and ML. Continue this, and we have, between the AI and the ML analysis, the combination of the quality issues and the vibration anomaly, we trigger a new work order. When I say we, electronically, the artificial intelligence will trigger a new work order in your computerized maintenance management system, your maintenance system. The algorithm can continue to check historical similar events and possibly suggest a proper procedure, technician, parts that's needed to remedy. Take even a step further. Your manufacturing execution systems can use the same analysis. And again, with that concept of the unified namespace, all of this data is available to all of these applications. It can check historical similar events, upcoming production runs. So what are our sales demands and the production scheduling around it, even supply chain metrics to know the parts we need, the raw materials, and so forth. Combination of all of this information, the AI algorithm can determine, hey, if we actually slow down production speed by a few percent, it might actually mitigate the quality issues, take care of the other problems, and retain optimal overall equipment effectiveness given these current conditions without having any business impact. How would we as humans do all this? Very, very difficult, if not impossible. This type of intelligence can happen real time. And this is one of the major promises and excitement about AI. Whenever we get into this kind of stuff, people always think, all this artificial intelligence and robotics are going to take away jobs. People win with AI. People win with automation, not the robots. And it goes back to all of the previous industrial revolutions. So the digital transformation is all about creating communication, collaboration, and connectivity, reducing silos, both data silos and human silos, empowering people and enabling creativity. So a couple of examples here. This device right here is a knitting machine created by William Lee about 1589, and it basically automated the process of creating stockings, and it worked, and it was great. When William Lee tried to apply for a patent, Queen Elizabeth I denied that patent, saying that it would deprive her subjects' employments, making them beggars. Well, luckily, the UK continued on anyway and became a worldwide leader in textile manufacturing over the next several centuries. A more modern example is automatic teller machines, ATMs, cash machines. I remember when they first came out, and there was a lot of talk about, oh my gosh, this is sort of the end of the bank teller position. Well, as more and more ATMs were added to the marketplace, where we could all go get our cash, bank teller positions actually started to rise and then dramatically rise above levels never seen before. So that was quite the reverse of what people thought. Why did this happen? Well, what happened was these bank tellers were freed up from performing mundane transactional type activities, and were now able to have more substantive conversations with customers, providing better bank customer service, and even talking about different products and services that the banks had to offer. The banks loved this, and they started to actually add additional tellers. Modern artificial intelligence, modern automation, Industry 4.0 technologies are going to do the same thing. We need to work side by side with these smart robots and these AI algorithms and all this amazing software that optimizes our maintenance operations floor. It's going to change the way we work. It's going to change the jobs and roles we have. But like all historical industrial revolutions, it will be for the better. So in the digital maturity model, where are you? Where are you in the spectrum? Well, you got to have computers and you have to have the connectivity. And if you're not yet even getting basic alarms off your assets, well, you're really not any smarter than chimpanzee. I see this level here, level 3 here, as the starting point for Industry 4.0. You've got to get to this point here. And again, this is a journey. You don't have to do it all today. But when you get to this point of visibility, you're starting to get the data in, you can start to make real-time data-driven decisions. That's where the intelligence really picks up. And as we continue on this Industry 4.0 journey and start to get into this really, really amazing and cost controlling and profitability inspiring technologies on this other end of the digital maturity model. If you're not anywhere up here, that's fine. You just have to embrace this. You have to get started and work towards this end to take advantage of these technologies. So in conclusion, number one, at least be smarter than a chimpanzee. You got to get started on these basics, get started on your digital maturity model so you can start to harness Industry 4.0 technologies, including AI. It's going to require some cultural changes. You have to embrace Industry 4.0 and AI and recognize it can leverage value. Just because your organization's been doing something the same way for the last 10 years or 25 years or 100 years doesn't mean you have to do it that way in the future. I can guarantee you your competition is probably thinking about this, and you'll be vulnerable if you're not going to adapt to these modern environments. They're getting less expensive and easier to implement all the time. Upstart competitors create more vulnerability for you in the marketplace. Remember that compression of time. Things are changing faster and faster than we've ever seen on this planet. You have to start your digital maturity journey. If you have any questions or you want to talk more about this for your organization, feel free to reach out to me. Thank you very much for your time today.